It's evidence for a distant giant planet in the solar system. So the authors here are Batikin and Brown, and a big part of the reason why we're back down to 8 planets is because Brown, is his other name, is better known as Pluto Killer, because he's the guy who kind of got Pluto demoted from planet status to just another dwarf planet by basically discovering lots of other dwarf planets and pointing out that Pluto really is nothing special, and if we're not careful we're going to end up with thousands of planets in the solar system this way. So he's killed one, and clearly guilt has got the better of him because now he's trying to bring one back. Basically they found evidence for a large-ish 9th planet in the outer solar system. So they haven't actually seen the planet, is the important point to get in first. They have come across indirect evidence that there probably is a planet out there somewhere. And because it's indirect evidence, you can't make very definite statements about it, but it has to be at least 10 times the mass of the Earth. So you're talking about a serious sized planet. It's not just, another little Pluto. It really is a serious planet we're talking about here. Planets are actually quite hard things to spot, especially ones which are a long way from the sun, because a planet doesn't actually give out any light of its own. All you're seeing is the reflected light from the sun. So when you get out to large distances, there isn't a lot of reflected light out there. And so actually by the time it gets from the sun to the planet and then reflected back to us, they really are very faint. Plus there's a lot of space out there. So the way you typically find minor bodies like asteroids and things is you take a picture and then you take another picture and you see what's moved. Now these things will move relatively slowly, so it's again quite a tricky exercise to actually track them down. Having said that, something this big really should be findable. So having now made a prediction of what it roughly is and roughly where to look for it, I suspect there will now be a concerted effort, and if it's there it will probably be found. So the primary piece of evidence is that there are a whole bunch of these things called Kuiper Belt objects, these sort of low mass objects in the outer solar system, and you can see there's a whole family of them which are all pointing in really pretty much the same direction in space. And if you do a kind of calculation to say, well, what's the chances of all these things being that closely lined up? It turns out it's a very low probability that they'll get lined up that closely. So the sun's in the middle there, and they're on these very elliptical orbits that carry them around the sun.
I didn't know Kuiper Belt objects had orbits quite so eccentric or came that close to the sun.
There are different families of them, but there are these ones that cross into the inner solar system and then whiz back out again. Well, it depends how you define the inner solar system. We think of them all being out in this thing called the Oort cloud, but actually quite a lot of them are on these kind of orbits that carry them in. Within the orbit of Neptune, so they actually come into the.
They're not going to smash into Earth.
No, they're not going to smash. No. So yes, don't worry about a Kuiper Belt object falling on your head. But yeah, they do. They are on these very eccentric orbits. Now, the interesting thing about that, how do they end up aligned like that? Well, maybe however they got made in the first place just had some preferential direction in it that for whatever reason they all ended up forming on these orbits. Because once you put a planet on an orbit, it stays on the same orbit and it'll just stay there. But the interesting thing is, because they are coming quite close into the inner parts of the solar system, they get relatively close to some of the outer planets. And the net effect of that over many orbits is that they'll gravitationally interact with them, and those orbits will kind of get scattered. So instead of pointing that way, maybe a bit later on it will have a close encounter and end up coming out in that direction. And you can do a calculation to say, well, what's the lifetime? How long would they stay if they formed in these? And the answer is, at least on the timescale of the life of the solar system, it's quite short. If they formed in that pattern, they won't have stayed in that pattern to the present day. So we know it can't just be the origins of it. So that means there has to be something holding them together. Now, there are usually 2 ways you can kind of hold a pattern of things together like that. It can either be the gravity of the things themselves holding it together, or it can be kind of something else marshalling it. And so you can do a calculation to figure out, okay, so how much mass is there out there in these kind of objects? Is it enough for the sort of mutual gravity of it to hold it together? And it turns out it fails by some very large fraction. So actually that can't be the explanation, which means you need something else that's marshalling them. And that was sort of the first piece of evidence that you need something else out there in that outer solar system that actually leads to this arrangement of them. People hadn't really thought about what could do that, and one of the nice things that comes out of this paper is they've done a whole bunch of simulations to say, okay, so what could be doing it? It has to be a reasonably massive body to have this effect. It has to be about 10 times the mass of the Earth or more. And when you've got a massive body like that, it turns out that the interaction between something on this anti-aligned orbit with this collection of things over here is enough to keep them relatively well marshalled together. And you can see they're not perfectly aligned, so actually there clearly are things going on, but it's enough to stop them from wandering too far away. And if that were the end of the story, I would kind of say, well, it's one of those things where they found something, and yes, it's a low probability, but maybe how did they collect them in the first place? How did they select the data? Which things have they ignored? But they found that if you make this planet 9 on that kind of orbit, it does a couple of other things as well, which also turn out to be things that we know about. So for example, there's another of these minor bodies, Sedna, and it has a couple of friends as well, which is on a rather strange orbit for these Kuiper Belt objects. Most of these Kuiper Belt objects are on orbits which at some point in their orbit get close to Neptune. Sedna is not on one of those orbits. And so for a long time people have wondered, well, how did it end up on that orbit, given that we think that the way you end up with these kinds of orbits is by close interactions with Neptune. And what they found is that if you've got this planet 9, once in a while it kicks something off one of these sort of Neptune encountering orbits onto a completely different orbit, just like the kind of orbit that Sedna's on. So now they've got an explanation for where Sedna comes from. And then the final piece of the jigsaw is they also found, sort of unexpectedly while they're doing this calculation, is that there's a completely different family of planets as well, minor planets as well. So these Kuiper Belt objects, which end up on orbits which are kind of perpendicular to the plane of the solar system. So all of these things are more or less in the plane of the solar system. You end up with another family which is almost perpendicular to it. And they thought, well, that can't be right. But then they went and checked, and it turns out there are a whole bunch of things on these perpendicular orbits as well. So by invoking this one rather extreme idea, namely there's a ninth rather large planet in the outer solar system, you can explain 3 things. And scientifically, that starts to look like a win, right? In science, if you dream up something which only explains one thing, you kind of think, well, you know, it could be anything, it could be that, it could be something else. But it starts to get more efficient if you've got one thing that you've dreamed up that actually explains 3 different things. At that point, you start to say, well, maybe that's, you know, the evidence is building up. Maybe that really is the way things work, and maybe there is that 9th planet lurking out there somewhere. So it'll have to be one of these things that's sort of like an ice giant, like Neptune or Uranus, one of those big gaseous, very cold bodies. When you do simulations of the formation of solar systems, stellar systems with planets around them, you do actually sometimes find that the planetary system starts to form, and then several of the big planets which are forming have a close encounter with each other, and one of them kind of gets gravitationally kicked out. So it is actually quite plausible there could be a large body which probably initially formed rather closer to the Sun, but then as the system formed, it then got kicked out onto one of these orbits. Now then you have to do something else to it, because if you just kick it out, it'll end up on a very elliptical orbit. But if it gets kicked out and then encounters, you know, some of the minor bodies out there, or gas or something that it can gravitationally interact with, then it can get on the more circular orbit and end up very much like the planet we see.
If you enjoyed this video and want to see even more astronomy, I hope you know about our other channel, Deep Sky Videos. It's really a lot like this channel, but astronomy only. We have lots of fun over there, and I hope you might check it out.
So you can see how much light is lost coming through that filter, because it's not very bright at all.
And if you find the history of science interesting, why not check out my other channel, Objectivity. Each week we go into the vaults and archives and find all sorts of amazing objects to do with the history of space, astronomy, physics, chemistry, you name it.
My word.
Yeah?
Yeah.
Liking it?
They're really cool videos and worth a look. I'll put links on the screen and in the video description.